Hi everyone, today we are going to talk about integrating by substitution. So sometimes when you're trying to evaluate an integral, you can simply just plug it into a formula. However, sometimes we can encounter situations like this. Evaluate the integral of a simple term times a composite function. And in this case, there is no specific formula just for it. Therefore, the mathematicians have come up with a solution, which is to replace the inner function of the composite function by a variable called u. In this case, u equals gx. And after that, rewrite the original equation into the integral of u du, which is a simple integral that can be solved by plugging into a formula. So let's try out a few examples with this. Number one, find the integral of 2x x squared plus 1 squared dx. So in this case, our fx is the squared, right? And the gx, the inner function, would be x squared plus 1, and I'll set it to u in this example, and du dx would be 2x. And if you observe the original integral, you will see that du dx matches with the simple term at the front. And therefore, we can rewrite the equation into the integral of du dx times u squared dx. And dx cancel out with each other, and we're left with integral of u squared du. And if we evaluate that, we would get 1/3 u cubed du. No, sorry, we don't need the du anymore, plus c. And then we're going to plug x squared plus 1 back into u. Therefore, the final answer would just be 1/3 x squared plus 1 cubed plus c. But what if the derivative of u doesn't match the simple term? Well, then we have to convert the simple term at the front into the derivative of u first before we do anything else. Let's try another example. Number 2, evaluate the integral of x squared plus 1 squared dx. In this case, u would still be x squared plus 1, and du dx equals 2x. And now 2x doesn't match with x, therefore we need to convert x into the derivative of u. And we know that 2 times x equals to 2x, which equals to du dx. And therefore, 1/2 du dx equals to x, which is a simple term. After we have converted the derivative of u into the simple term, then we're going to rewrite the original integral in terms of u. So integral of 1/2 du dx times u squared dx, and dx cancels out with each other, and we're left with 1/2 integral of u squared du. And if we evaluate that, we would get 1/2 integral 1/3. Oh, sorry. It should be 1/2 u cubed plus c, which equals 1 over 6 u cubed plus c. And if we plug x squared plus 1 back into u, we'll get the final answer, which is 1 over 6 x squared plus 1 cubed plus c.